looking at 8.1, which is translation. Your S and L right here are highlighted because they're going to help us remember when we think of a translation, we're going to think of a slide because it's going to slide from one spot to another. It doesn't rotate or turn. It just literally, it's like sliding it around. So it moves each point of the figure the same distance and the same direction. The points can move up and down, or they can move left and right. So it can be slid to the left and up, to the left and down, or it could be slid to the right and up, or the right and down, but it's just being slid. So you never lift it off the paper. Your X value, so the first, the X value is going to tell us whether we're going to move left or right. If we move left, it's going to be a negative number. If we move right, it will be a positive number. The other one will tell you to either move up or down, and that will be the Y value. Up is positive, and down is negative. So a verbal description would be me saying to you, in words, this would be the verbal description. Translate the figure 4 units to the left and then 2 units up. So you would take each point and count 4 units to the left and then go 2 units up. Algebraically, this is what it would look like. Normally, we start with just X, comma, Y. That's what it is. My normal X, my normal Y. When we translate it, it becomes written as X. And if we are going left, that's a negative. So we would go left 4. In other words, take every X value that you have and subtract 4. That will move it to the left 4. And then we're going to take every Y value we have and we're going to go up 2. So we're going to add 2. So every one of these starts like this. This is our original, and here's how we're going to get our new point. So this is written verbal, and this is how it would be written algebraically. All right, so let's look at this. So we're going to go 6 units to the left and 4 units down. So I have A, point A. So again, our pre-image points are always going to be the ABC. Pre-image is our original before movement. Our image is it's been moved, it's been copied to another location. So we're going to have A prime, B prime, and C prime. So it already told us that A is at 2, 4, over 2, up 4. B is over 6 and up 7. And C is over 7 and up 3. Now we have our original points. We're going to take A and we're going to go 6 units to the left. 1, 2, 3, 4, 5, 6, 7. I'm not done though. Whoops, not 7. 6 units to the left. So I'd have 1, 2, 3, 4, 5, 6. And so that would be 6 to the left. And then I'm going to go 4 units down. So 1, 2, 3, 4. And I'm going to mark that. I'm actually going to erase that. I only wanted you to see what I was doing so you could follow me. And now A was here. Again, pre-image. My image point is the copied one. So it's almost like it left a mark when we copied it. Then I'm going to do the same thing for B. So I'm going to count over 6. So 1, 2, 3, 4, 5, 6. And then I'm going to go down 4. 1, 2, 3, 4. And this will be B prime. And then C, same thing. 6. 1, 2, 3, 4, 5, 6, and down 4. 1, 2, 3, 4. So now I have this shape right here. And all I did was start here and slide it here and down, and it would line up exactly. So my new points for A, my pre-image points were at 2, 4. My prime, or my image points that are moved, were at -4, 0. B prime was at 0, +3. And C prime started right here, but after we slid it, C prime became 1, -1. So if we look at these, if we look at each of our x value, I started at 2, I ended at -4. I started at 6, I ended at 0. I started at 7, I ended at 1. I can tell that from my pre-image, my original point to my new, or my image point, there was a decrease in number. My number got smaller in value, and it got smaller by 6. And that's because I went 6 units to the left, so it should be getting smaller. Then if I look at my y values, I started at 4, I ended at 0. I started at 7, I ended at 3. Started at 3, ended at -1. Those also decreased, and to get from my pre-image to my image point, it decreased by 4. So algebraically, this would be written, I took my original x value and I subtracted 6 from those x values. I took my original y value and I subtracted 4 from my original y values because I decreased on both of these. If any of them were an increase, it would have been a plus. So what this means is I could have taken this 2 right here and replaced it with this x right here. I could have swapped them out. And so 2 minus 6 would have given me that -4 right there. Then I could have taken my y, which was 4, and plugged it in here and said my original y, which was 4, minus 4 is 0. And that's how I could get points that way. I can replace each x value in here, each y value in here, and get my new points. Now, we just counted and moved them. That also works, but there's a faster way to do it. Okay, so this one wants us to translate or slide GHI to the answer. It is important on here that you start from your pre-image and move to your image. You can see that this was my image that was moved. That means that I slid over and then up. That's how this object moved. I don't care which point you start at. I'm going to start with H right here. Now point H right here starts, and I'm going to just trace where it went from here, then it turned and went up, and it ended. So let's figure out what this actually did. I started at 2, and I went 1, 2, 3, 4, 5, 6, 7. That means that I slid it 7 units, and I moved it from my pre-image to my image. So from my original to the copied, I moved it 7 units. So I'm going to say I translate 7 units, and I went to the left. Then after I was done sliding it to the left, I translated 1, 2, 3, 4 units up. So 7 units left and 4 units up. So algebraically, we took each of our x values, which in this case my x was 2, and I subtracted 7 from it. So 2 minus 7 would give me 5, which is exactly where I ended before I started moving up. I took each of my y values, and this says to add 4 because we're going 4 units up. So originally my x was 2, I subtracted 7, I ended at -5. Originally my y was -1, but when I moved it up 4, it became 3. So I just slid it over and then up. I could take this whole shape right here, slide it over and up, and it would end up right on top of that. So it says, does this translation show a rigid transformation? Now, a rigid transformation is in your vocabulary. That means it stays the same size, same shape. I didn't change the size of this. I didn't change the shape at all. All I did was slid it around. So does it show a rigid transformation? Yes, comma, stayed the same size and same shape. All right. Now let's try this one. Again, we're going to have R prime, A prime, and D prime because math is rad. Meaning, here are my original points. Here's where my points are going to end up. Pre-image, copied image. So it tells me Fred plans to translate, or he plans to slide the triangle 9 units to the right. To the right is a positive, and then 9 units down is a negative. So it says, describe how you could find the coordinates for the image without physically moving it. Well, algebraically, this says take each x value and move it 9 units to the right. So that's what that would look like. And then it says take each y value and go 9 units down. So in words, how to say this is not subtract. We're going to add 9 to each x value. And then we're going to subtract 9 from each y value, because that's what we're doing. If you visualize a number line, if you started at -7 on the x-axis and you slide it 9 to the right, where would you end up? In other words, if I take -7 and I put it in here, it would be -7 plus 9. That would give me 2. If I take my original y, which was 2, and I plug it in here, 2 minus 9 is -7. Same thing. I start with an x value of -2, so I swap out my x. -2 plus 9 is going to be 7. I plug in my y. 2 minus 9 is -7. So I'm going to add 9 to my x value, which will give me 7. And I'm going to subtract 9 from my y value, which will give me -2. And that's what my new points would be. All right, now we're going to look at, sometimes they're going to just give you coordinates. So like right here, it says the coordinates of a pre-image and image are given to you. Use the points to give not only the verbal, but the algebraic description or representation. So in other words, here's my original, here's my moved. I started at 12. What did I do to 12 to get to -1? Well, knowing that this is my x value, I moved from a positive 12 on my x-axis. So my x-axis goes this way. My y-axis goes this way. So I'd be to 12, which would be, to the far right, and I ended at -1, which means I moved to the left. I went from a positive to a negative. That means that I translated 13 units left. I started at 7 and I ended at 14. So on my y, I started at 7, but I went up to 14 before I stopped. So that means that I went 7 units up. So algebraically, I'd say I took each x value and I subtracted 13 units, but I take each y value and I add 7 to it to get my new one. All right, try 5 and 6 on your own.